Ever wondered how airplanes gracefully navigate the skies? It all begins with a fascinating branch of physics, aerodynamics. Welcome aboard to AM Risk and Training, the confluence of safety and aviation expertise. Today, we are thrilled to unveil our Aircraft Technical Overview and Aircraft Construction Training course. This intense 5-day curriculum is crafted to endow your firefighting crew with the acumen and techniques crucial for aircraft emergencies. Over the span of 40 hours, inclusive of a 2-hour evaluation and 6 hours of hands-on training, attendees will delve into the intricacies of aircraft construction materials, fuel variants, onboard apparatus, firefighting strategies, and beyond. All orchestrated in compliance with ICAO Annexure 14 and Doc 9137. Before we delve into the nuts and bolts of aircraft construction, let's take a moment to appreciate the science that makes flight possible. Aerodynamics. The term aerodynamics emanates from the Greek words aer, meaning air, and dyne, meaning force. Simply put, aerodynamics is the science that studies the motion of air and how it interacts with solid objects like an aircraft. As we display the word aerodynamics on screen, let's dissect its Greek roots. The first part, aer, signifies air, while the second part, dyne, represents force. Together they encapsulate the essence of flight. To further illustrate, let's visualize a simple animation showcasing atmospheric gas motion. Notice how the gases move around an object, reacting to both gravity and mechanical forces. This is the core of aerodynamics, the magic that enables massive metal structures to soar gracefully through the skies. Understanding aerodynamics is not just about flight. It's about comprehending the interplay between various forces and how they influence an aircraft's performance. As we move forward, we'll see how this understanding shapes the construction and operation of an aircraft, making it a key component in our training course. Before we delve into the nitty-gritty of aircraft construction, it's crucial to grasp some basic concepts that underpin the principles of flight. As we transition to a serene shot of clouds and blue skies, let's take a moment to comprehend the fundamental ideas that lay the groundwork for understanding flight. The properties of air, which we've explored in our previous segment, have a profound impact on how aircraft operate and are controlled. To illustrate this, let's bring up some visual aids on the screen. Notice how the properties of air, such as temperature, pressure, and density, interact with the aircraft. This interaction is the basis of flight control and operation. Understanding these principles is vital to gain a deeper insight into aircraft construction, which we'll be exploring in the following segment. So, hold on to your seats as we prepare to take off into the fascinating world of flight principles. As we transition from understanding the principles of flight, it's time to delve into the magic that makes it all possible. Lift. The concept of lift is what separates an airplane from a car. It's the force that opposes gravity and allows an aircraft to rise into the sky. As we cue a series of diagrams on the screen, let's dissect the theory behind lift. You see, when a plane moves through the air pressure above the wings is lower than the pressure below, creating an upward force we call lift. This invisible force is created due to the special shape of the wing, known as an airfoil, which we'll examine in detail in the next segment on aircraft construction. Keep in mind, the speed and the angle at which the airplane moves also significantly affect the amount of lift generated. So, buckle up as we continue our journey through the fascinating world of aerodynamics and aircraft construction. Having understood how planes achieve flight, let's delve deeper into one of the crucial components that make this possible: the airplane wings. A plane's wings are designed in a specific shape known as an airfoil. This design is critical in creating lift, the force that opposes gravity and allows a plane to rise. As we display a detailed 3D model on the screen, let's discuss the airfoil shape. The top surface of the wing is curved, while the bottom surface is flatter. This design difference causes the air above the wing to move faster than the air below, creating a difference in pressure. This pressure difference is the key to generating lift. The higher pressure beneath the wing pushes upwards, lifting the plane off the ground and into the air. Remember, the size, shape, and angle of the wings can greatly influence the amount of lift generated. As we move into the next segment, we'll discuss the construction of these wings and other components of an aircraft that contribute to its ability to fly. So stay tuned as we continue our journey through the fascinating world of aerodynamics and aircraft construction. From understanding density, pressure and temperature to mastering Newton's laws of motion, participants will explore the fundamentals. They'll grasp the intricacies of aircraft airflow, flight controls, and the vital role of primary and secondary flight controls. But it's not just theory. Our course ensures hands-on experience, locating safety equipment, identifying fuels, and operating essential firefighting tools. We believe that practical knowledge is the key to effective emergency response. By the end of this course, your team will be equipped to identify various aircraft, extinguishers, cargo compartments, and respond confidently to aircraft incidents involving dangerous goods. Saving lives begins with preparation. Join AM Risk and Training in shaping a safer aviation landscape. Enroll in our Aircraft Technical Overview and Aircraft Construction Training course today. Contact us with the link in the bio or get us on our website on the contacts page. Together, let's elevate safety standards and ensure a secure future in aviation.